Hi guys. Well, as I said in the last session, we will be looking at applications of logarithms in this particular video. So I hope you have all gone through the second video of mine very thoroughly and you're all very clear about the formulae and their manipulation, because we're going to put that to test and to use in today's class. So we're going to look at a bunch of questions that have appeared in various entrance exams. Let's start with the first question for the day. Okay, that's about me. I'm going to skip this part. Right. So the first question over here, we're going to look at the number of solutions of this particular equation. Now, if you observe here, you will notice that the base here is 4 and the base here is 2. So you can't obviously compare x minus 1 and x minus 3 directly. So think of a way of how to do this. Pause the video if you want. Right guys, so what is the idea? So the idea here is you convert this 4 into 2, or you convert this 2 into 4. Now how do we do that? We all know that I can write my left hand side as log x minus 1 and I can write it as 2 square. And right hand side, okay, before going into right hand side, let me simplify this. This will become half log x minus 1 to the base 2, which is equal to right hand side now x minus 3 base 2. Now if I bring this 2 to the right hand side, this will become log x minus 1 to the base 2, which is equal to 2 log x minus 3 to the base 2. Now this I can take it to the power of x minus 3 because we have the exponential form. So what will this become if I do that? This will become log x minus 1 to the base 2 is equal to log of x minus 3 whole square to the base 2. Now if you notice, the bases are same, so I can directly compare this x minus 1 and x minus 3 whole square. So when I compare this, what do I get? I get x minus 1 is equal to x minus 3 the whole square. So from here I'll get x minus 1 is equal to x square minus 6x plus 9. So if I group the terms together, I'll get x square minus 6x plus 10, minus 7x. Minus 7x plus 10 is equal to 0. And I can factorize this because 10 is 5 into 2. So I can factorize this as x minus 5 into x minus 2 equal to 0. So I hope you know the basic factorization of quadratic equations. So it means your x can be equal to 5 or x can be equal to 2, but this is the trap. Do not blindly go and mark option C. Please don't do that. You have to check, can my option 2 be, can my x equal to 2 be possible in the original question? If you look at the right hand side, when x is 2, your right hand side becomes log of minus 1 to the base 2. This is invalid because logarithm is not valid for negative numbers. Hence, you cannot have x equal to 2. This option is rejected, or this answer is rejected. Similarly, check for 5. When you put x equal to 5 on the left hand side, it will become log of 4 base 4 is equal to, on the right hand side, log of 2 base 2, and this is correct. This is valid. So you got only one correct answer for x. So the answer is option B. Now you need to ask, or you need to understand, why is this happening? Why am I getting two answers out of which one is rejected? Because when you manipulate an algebraic expression and you convert it into a square term, you get extra possible roots which may or may not satisfy the original condition. So I'll explain to you what it means. So if I start with x equal to 2, then if I square it, x square equal to 4. Now if I write x, I'll get x equal to plus or minus 2. If you notice, when you square something and then you solve for the answer, you will get you might get extra answers compared to what you're actually starting with. So you will discard minus 2 in this and you will only stick with plus 2. because you can't start x with 2 and then say x is plus or minus 2, because originally x is positive in this small example of mine. So the thing that you have to keep in mind is when you're squaring or when you're manipulating something such that it is becoming a square, whenever you're manipulating something that it is becoming a square or an even power, and then you're solving for x, there is a chance for you to get extra answers. So please be careful. Never directly mark your final answer without checking for all values of x. Right? Fine. Let's move on to the next question. There's a next question. So we have 3 power x equal to 4 power x minus 1. So I will just simplify this. So those of you who want to try it out, please pause the video and try it out. While for those of you who are relaxing and watching the video, I'm just continuing it. So I will write it as 3 power x is equal to 4 power x by 4. So I can write it as 3 power x by 4 power x equal to 1 by 4. Or I can write this as 3 by 4 whole power x equal to 1 by 4. Okay, now this is of the form a power x equal to b, which means if I apply logarithm, if you remember my first video of logarithm, I can write x equal to log b base a. So I will write x equal to log of 3 by 4 to the base 1 by 4. Sorry, my mistake. Log of 1 by 4 to the base 3 by 4. Now, if you notice, there is no 4 over here. You have only base 3 or base 2 in the options, which means you can manipulate this x as log of 1 minus log 4 by log 3 minus log 4. And let me take the common base as, I'll keep the base open. Now remember, all these bases should be same in your base manipulation. So right now I'm just not writing a base. It can be any base, but the same base for everything. Now what will this become? This becomes x equal to, now log 1 is 0, so it is minus log 4 by log 3 minus log 4. I can write this further as x equal to, I will take negative cancelling out numerator and denominator. I will get it as log 4 minus log 3. Now it is somewhat in the pattern that I want. Now look at my log 4. I can write it as base 3 everywhere because we already discussed the base can be anything. I did not write the base, I kept the base open. So if I write this, I can write my log 4 as 2 square. So my x can be written as log 2 square base 3 by again log 2 square base 3 minus log 3 base 3 is 1. So this becomes 2 log 2 base 3 by 2 log 2 base 3 minus 1, which is your option A. But this is an interesting question. I have thrown in a little bit of multiple answer correct. So this is not the only answer correct. If you observe option B, it is taken to base 2. It is taken to base 2, which means in applying the base here, instead of 3, if I erase this, what all I got by putting base 3, instead of 3, if I apply log base 2, what happens? If I write 2 here, I will get my option B. You can notice x will become equal to 2 log 2 base 2 by 2 log 2 base 2 minus log 3 base 2, which is equal to 2 by 2 minus log 3 base 2, which is very clearly option number B. This is also correct. The job doesn't end there. If you observe option C, you will also get option C. You will also get option C when you apply the log as base 4. Depending upon what base you're putting, you will get a different answer. But all of them mean the same answer. Basically, all of them are same. The value wise, they're all same. But the expression, the way to look at it, I mean, at least the looking, they will be looking different. So what does it become? So x becomes 1 by 1 minus log 3 base 4. So C is also correct. And you can try for option D, but you will not get option D because we already applied log base 2. When it is base 2, it is option B and not option D. So there are 3 correct answers, and the reason why I gave this question this way is to show that there can be multiple ways of manipulating depending upon a small base change, and the answers can change in the nature in which they can look. That is the beauty or the problem of logarithms, whichever way you want to look at it. Okay, right guys, the next question, this is the question that you have. Right, so pause the video, take a look, and those of you who are enjoying it as a movie with the popcorn, let's follow with the solution. So before I solve, let me take log x base 2 as a. So my left hand side becomes x to the power of 3 by 4 into a square plus a minus 5 by 4 is equal to root 2. So I can call this entire thing, if I say this is b, my left hand side is in the form of x to the power of b equal to root 2. Now I can apply logarithm, or I can write b using logarithms. By the definition of logarithm, I can write it as root 2 base x. So I can write this as half log 2 base x. So this will become my b is 3a square plus 4a minus 5 by 4 is equal to half log 2 base x. Now right hand side I can write it as 1 by 2 and I can write it as log x base 2. Now if you notice, I am bringing my logarithm to the denominator, right? So inverse formula of logarithm I'll use. So this will become 1 by 2a. So my left hand side and right hand side, if I write once again, it is 3a square plus 4a minus 5 by 4 is equal to 1 by 2a. Okay, so what happens here? If I bring, or if I multiply both sides with 2a, rather I will bring this 2a here. So this will become 3a square plus 4a minus 5 by 4 minus or into 2a is equal to 1. Okay, so this gives me a cubic equation, but that's okay. I will write it as 3a square, or in fact I'll do one thing. I'll take this 4 here and then bring that 4 to the left hand side. So my left hand side totally becomes 3 2s are 6a square, or 6a cube, sorry, plus 8a square minus 10a minus 4 equal to 0. So this is a proper cubic equation. Don't sit and solve for this cubic equation here. Try to observe what is happening. 2 is common, right? 2 is, in fact, I could have cancelled out 2. So let me just cancel out 2, which is common here. So this becomes 3a cube plus 4a square minus 5a minus 2 equal to 0. Now let's just observe and see, can we find the roots just by looking at this? And you'll notice that when you put a equal to 1, your left hand side becomes 0. Your left hand side becomes 0, which means a equal to 1 is a root of this cubic. A equal to 1 becomes a root of this cubic. So my cubic equation can be written as, if you remember the basics of polynomials, one of the factors is a minus 1. The remaining will be a quadratic. Now remember it, and then this is equal to 0, which means clearly a equal to 1 is a solution. A equal to 1 means log x base 2 is equal to 1, or x equal to 2 power 1. Definitely there is 1. Okay, definitely there is 1, and it is not irrational, which means option D is incorrect because we got a real root, and option C is incorrect because it is rational. 2 power 1 is 2, it is rational. Now we have to decide between A and B. Is it the only solution we have, or do we have more than one solution? Okay, So let's look at what will be the remaining quadratic equation if we take out a minus 1 as the common value. So if you do synthetic division, or if you can observe things over here, um, you will be able to get. So if you can observe here, you can write the remaining quadratic equation as 3a square plus 7a minus 2. You can also, by observation, if you're good at observing, you can get this, or you follow the synthetic division. I hope all of you remember. Divide this entire cubic with a minus 1, and the remaining will be this. So if this is equal to 0, then the other two roots, you can get it from 3a square plus 7a minus 2 equal to 0. So you can write a equal to minus 7 plus or minus root of b square 49 minus 4ac, so minus of 4 a c is negative 2 by 2 into 3. Now you can see that this is a is a real number. This is a real number, which means log, let's call this, there are two answers here because there is minus 7 plus or minus. So I have minus 7 plus one number and minus 7 minus one number. Let's call them as k1 and k2 values. So I have log x base 2, which is the value of a, which is equal to k1 or k2, which means x equal to 2 power k1 or x equal to 2 power k2, which clearly means these two are real answers. Because remember, k1 and k2 are real numbers. So 2 power k1 and 2 power k2 are real solutions. So we already got one solution, which is 2 power 1. Then we have two more answers, 2 power k1 and 2 power k2. K1, k2 are this big entire. You don't have to worry about the simplification because they are not asking you, thankfully, what is x. They are saying how many x's are there. So you can clearly see that there are three real solutions. Three real solutions. Okay. Well, it was a bit lengthy, no doubt, but let's move forward. Okay. This is a question. It's an interesting series. Please take a look at it, pause the video and solve. For the others, I'm just continuing. So we will have to first solve the part over here. So let's take, so this is a typical concept when things are repetitive in nature. So you start with, let this entire thing 4 minus 1 by 3 root 2 root of 4 minus 1 by 3 root 2. You'll start by saying let this entire thing be x up to infinity. So now if I highlight only the red part and if you look at only this, it is actually x itself, because if you're starting from here and going till infinity, it's the same thing that you get, right? So this tells you that you can write this as root of 4 minus 1 by 3 root 2 and the entire remaining thing is x is equal to x again. This is the peculiar way of solving such infinite series which are repetitive in nature. So if you square it on both sides, you will get 4 minus x by 3 root 2 equal to x square, or if you bring things together, you'll get x square plus x by 3 root 2 minus 4 equal to 0. Now, one thing to keep in mind, root of anything by default is always positive. Do not commit the mistake of writing root of 4 as plus or minus 2. This is wrong. So this, for some of you who do not know this, remember guys, root is always by definition in mathematics positive. Then when do you get plus or minus? You write x square equal to 4, then x is plus or minus. But if I ask you x equal to root 4, directly the answer is always plus 2. It is important for you to understand this. Now, why is this important? Because the given question or the given x is supposed to be positive, because we have directly root of something. Root of something is never negative. Okay, so our answer that we get for x is also supposed to be positive only, and we will see why that knowledge is important. So if I use the formula for root, x equal to minus b plus or minus root of b square minus 4ac by 2a. This is the quadratic equation formula. So this gives you x equal to minus 1 by 3 root 2 plus or minus root of b square 1 by 9 into 2, 18. And negative of negative becomes positive 4ac. So 4 into 4, 16 by 2. So your x becomes, it looks very scary, but actually it is not. You can take a look at it. 2 plus or minus root of, now this numerator, when you simplify, take the LCM, becomes 289 by 18 by 2. And clearly 289 is 17 square. So very nicely your x will become minus 1 by 3 root 2 plus or minus 17 by, now remember, root 18 is again 3 root 2 by 2. So this becomes minus 1 plus or minus 17 by 3 root 2 into 2. So you have two possibilities here. It is minus 1 plus 17, which means 16 by 3 root 2 into 2, or minus 1 minus 17, which is minus 18 by 3 root 2 into 2. This gives you 8 by 3 root 2. This gives you minus 6, so minus 3 by root 2. But this answer is rejected. Why? Because we started off knowing that x is supposed to be positive. I just told you. If x is positive, I'm getting a final answer as x which is negative. I cannot accept it. Now, why did this happen? Because we manipulated by squaring on both sides. I already discussed, when you're squaring things on both sides, be careful about your final answers. So you get only one possible answer, which is 8 by 3 root 2. 8 by 3 root 2. So your entire expression now becomes 6 plus log 3 by 2 base and 1 by 3 root 2 into 8 by 3 root 2. Now this becomes meaningful and simple. So I'm just erasing a few parts so that I can make space to write once again. Right? Okay, so what do I get over here? I got 6 plus log of base is 3 by 2. There's no problem. Now, 8 is no problem. By 3 3s are 9 and root 2 into root 2 is 2. So this becomes 6 plus log 4 by 9 base 3 by 2. Now this is a nice small interesting manipulation. It is 6 plus log 2 by 3 whole square to the base 3 by 2. Correct? So what do we have here? This is 6 plus log, I can write it as 3 by 2 to the power of minus 2. Now how am I able to do that? Because if I have 2 by 3, I'm just writing it on the bottom here. If I have 2 by 3, I can write it as 3 by 2 to the power of minus 1. Basically taking 3 up and bringing 2 down. So the entire power will become negative. That is how I'm able to do this. So this will become 6 minus 2 log 3 by 2 to the base 3 by 2, which is basically 6 minus 2, and it is 4. So the answer finally is 4. Once again, a lengthy question. Now the second thing you need to understand about logarithms, usually they are not short and sweet. They will be a bit lengthy. If they are short and sweet, it's your lucky day. Okay. So guys, we have solved around 3 or 4 questions. It's been a lengthy session. I will break the session here. In the next session, we are going to continue with the application of logarithms. We'll see a few more questions. Right? See you in the next session.